Hello students, welcome back. In the previous class we learned the concept of betweenness, and today we are going to have a very important question based on this from exercise 1.1 question number 5. Let's have a look over the problem. So it is said points x, y and z are collinear such that distance of xy is equal to 17, distance of yz is equals to 8, distance of xz we need to find it out. So as it is said that the points x, y, z are collinear. If you remember students, we learned last time that if three points are collinear, there can be three possibilities for their betweenness. So just the same concept will be applicable here. Let's see how it can be done. So as it is said, point S, x, y and z are collinear. So there can be three possibilities regarding its betweenness. We'll discuss them as case 1, case 2 and case 3. We take case 1 where we can say that points have the betweenness x dash, y dash, z. Right. That y can be in between. In the case 2 you can take x as in between of x and y and z. In the third case you can take z in between x and y. Now let's see. As x dash y dash z, so it means that distance of xy plus distance of yz is equal to distance of xz. So distance of xy plus distance of yz is equals to distance of xz. Let us simply substitute the values. Distance of xy you can see it is 17, distance of yz it is 8, and now we can find out distance of xz. 17 plus 8 will give you 25. So distance of xz is what? 25. This is what we have got, distance of xz with case 1. Now students, we will take case 2. So in case 1 you have taken y in between x and z. Now we can take z in between x and y. So our case 2 becomes x dash z dash y. And now I want you to apply the same property here. First second plus second third is equal to first third. So we get distance of xz plus distance of zy is equals to distance of xy. Distance of xz plus distance of zy is equals to distance of xy. Now let us substitute the values. Let's see distance of xz, that we need to find out. Distance of xz we need to find out. Distance of zy is given to be 8 and distance of xy is given 17. So this is plus, on shifting it will get subtracted. So distance of xz is equals to 18, 17 minus 8, which will give you 9. So we have got the distance of xz is equals to 9 as per the case number 2. Now students, now it is going to be case 3. So once we have taken y in between, second time we have taken z in between, now we'll take x in between y and z. So in case 3, we'll take x in between y and z. Now as we have done previously, we can see from here distance of yx plus distance of xz is equal to distance of yz. Let's write down over here. So distance of yx plus distance of xz is equal to distance of yz. Let's simply substitute the values. Distance of yx, that is xy, is 17. Distance of xz we don't know, and distance of yz is what students? 8. So 17 is plus, on the right side it will get subtracted. So distance of xz will be 8 minus 17, and distance of xz 8 minus 17, plus minus minus sign of greater number. So we'll get here minus 9. So what do we see here students? The distance of xz, this time we have got minus 9. But as we have learned in the basics that the distance between 2 points cannot be negative, so we'll simply write here, and this value we are going to ignore. So we'll write down here, since distance between 2 points cannot be negative, hence distance of xz is equal to -9 is not acceptable. So distance of xz will be the two values which we have got previously, 29, 5 and 9. Now this was a very important problem, and I hope you have understood this very well. Thank you, students. So now here we are going to study about some properties related to our topic, today's topic. We are going to first start with what? Congruent segments. Let's see what do we understand by this congruent segment. So students, if length of two segments are equal, then they are said to be congruent segment. Let me call this segment AB of 5 cm. There is another segment PQ, and suppose if we get the length of segment PQ also 5 cm, then we understand that length of AB is equal to length of PQ, and that is what our definition goes around. Congruent segment. If the length of two segments are equal, then we say those two segments are congruent, and it is the sign we use for congruency. We can say now here segment AB is congruent to segment PQ. After this, we'll see the second concept, that is midpoint of a segment. So our topic is midpoint of a segment. Now it's very clear by the name only, mid. Mid means what? It comes from the word middle. That means we are going to look for middle of a segment. What do we understand by middle of a segment? Mathematically we say that if 3 points A, M, B are collinear, that they should be in a straight line, and if distance of AM is equal to distance of MB, that is segment AM is congruent to what? Segment MB, at that very moment we say that M is midpoint of segment AB. Now students, repeating this once again, if 3 points A and B are collinear and segment AM is congruent to segment MB, we do say that M is midpoint of segment AB. Now students, this is a very important concept. We are often going to use this in geometry. If M is midpoint of segment AB, then we come across few results. What are the results? Let's understand this. We'll take this with another example. Suppose that I say that 3 points P, Q and R are collinear, and Q is the midpoint of segment PR. Then we need to understand, if PQ is 5, what will be the value of QR? Definitely QR will also be 5, as both are equal. What will be the total length of PR? And now we can see PQ is 5, QR is 5, so definitely PR is going to be what? 10. Now need to you to develop some relation between the segments. PQ is 5, QR is 5, so what you can say about PQ and QR? Yes, very good, they are equal, so we can say PQ is equals to what? QR. Now PQ is 5 and PR is 10. So what is the relation of PQ and PR? So we do see, as 5 is half of 10, so we can say that PQ will be half of 10. In the same way, if we relate QR with PQ, QR is 5, PR is 10, then what does the relation? Then definitely QR will also be half of PR. So that's how we conclude that PQ will be equal to QR and they will be half of PR. So this is the result we'll obtain every time when we have midpoint of segment. So I want you to apply the same formula over here and tell me what result do we get. So what we'll get here, AM is equals to MB is equals to half of AB. Fantastic. Now we'll do a problem based on this so that we can understand this problem very well.